Welcome back. Let's go ahead and talk about the case statement. The case construct allows us to test strings and numbers and is in fact a simpler form of the bash if, elif, else statements. If you already have experience in other programming languages, you should know that the case statement in bash is similar to the switch statement in C, C++, or Java. With case, the shell checks the conditions and controls the flow of the program. It serves as a kind of shorthand for multiple if, then, else statements. The bash case statement takes the following form. Each case statement starts with the case keyword, followed by a variable to test and the in keyword. The entire construct ends with the suck keyword, which is case spelled backwards. You can use multiple patterns separated by a vertical bar like a pipe. The parenthesis operator terminates the pattern list. A pattern can contain special characters like asterisks or question marks, and a pattern and its associated comments are known as a clause, and each clause must be terminated with double semicolons. The comments corresponding to the first pattern that matches the variable's value are executed. It is common practice to use the wildcard asterisk symbol as a final pattern to define the default case. This pattern will always match. After the first match, the case statement terminates with the exit status of the last command that was executed. Okay, let's see how it works with an example. I'm creating a new script, favorite_pet.sh. The user will enter his favorite pet, and based on his answer, the case statement will print out a specific message. It's a simple script. This time, I'm displaying the message using echo and -n. -n will make the echo command not add a new line after the string. And the string will be enter your favorite pet. And I'm reading the answer in a variable called pet. And now the case statement, case $pet in. The first pattern will be dog. Note that quoting the variables is not mandatory since word splitting does not take place. I'm displaying your favorite pet is dog. And don't forget double semicolons at the end of the condition block. And the second condition. This time, I'll add the vertical bar operator which separates multiple patterns. So cat, vertical bar, cat with a capital C, and the last one, let's say kitty. And echo, you like cakes. And double semicolons. And the last pattern. Fish, pipe, African turtle. If there's a string that contains spaces, it should be enclosed in double quotes. Echo, fish, or turtles are great. And finally, star parentheses, which is the default case that matches anything. So if the user enters another value, the statements of this pattern will be executed. Echo, your favorite pet is unknown. And the suck keyword, which terminates the case. Great. I'm saving the file, opening another terminal, setting the execution permission to the script and running it. I'm entering dog, and it said your favorite pet is dog. Now I'm entering cat. Great. And fish and another animal. Let's say parrot. The script works just fine. Let's see a second example, this time a real life one. I want to create a script that accepts two arguments. The first argument is the signal number and the second one is the process ID, and the script will send the signal number to the process ID. Let's say signal.sh. First, I'm checking that the script is run with exactly two arguments. Remember that the number of arguments is saved in the predefined variable $hash. So if the number of arguments is not equal to 2, then I'll exit. -ne2, then empty. I'm displaying a message to the user and then I'll exit. So echo, run the script with two arguments, signal and PID. And exit. 1. 1 will be the return status of the script. And the case statement. I'm sending the right signal based on the value of the first argument of the script. So case $1 in. If x1, I'm displaying a message and sending the signal to the process ID. So sending the SIGHAP signal to $2, the process ID. And I'm sending the signal using the kill command. By the way, if you want to see all the signals a process can receive, run kill-l. And you see that 1 is SIGHAP. Now the second signal. This time, I'm gonna send the SIGINT signal. And kill-SIGINT $2. And the last signal I'm gonna send will be 15 or SIGTERM. By the way, this is the default signal that is sent to a process in Linux. And the default clause. Echo signal number $1 will not be delivered. This is the case when the user selects another option, for example 10. And they suck. I'm saving the script, setting the execution mode and running it. In this terminal, I'm gonna run a command. For example, sleep 100 %. I'm running the command in the background. This is the process ID of the command. So, I have to run the script with two arguments, signal and PID. I've just run it without any arguments. So the signal is 1 and the PID 19718. Take a look here. The process was stopped. I'm trying it again. This time, I'm sending sigterm. And of course, I have to change the process ID. This time is 19733. And it's done. It was terminated. And once again, this time I'm sending another signal, for example 10, to the process ID. 19736. It will execute the commands corresponding to the default clause. Great! You are doing a fantastic job. Even though you may not realize it, you've already stacked a lot of knowledge. You now know how to add logic to your scripts using the if, elif, else construct, how to use multiple test conditions, and how to nest if-then statements for more complex situations. You are also able to use the case construct, which can replace if, elif, else for much more readability. Now I'll take a short break, and next I'll show you a very cool feature of Bash, which is how to build menus. I'll see you soon.